Hi guys, welcome to another lesson from Miss Evick. This lesson today is going to be reviewing what you've already learned about the real number system. Now I've put on the screen a picture, a diagram actually, a Venn diagram of all numbers that qualify as real. It sounds really funny to say that numbers are real, but they qualify. Every single number on this chart qualifies as a real number. I am actually going to pick this real number system apart and talk about all the subsets and all the categories based on the very innermost category, the very specific category, and that one is going to be natural numbers. Natural numbers are the most specific out of all categories in the real number system. Natural numbers, you could also think of them as counting numbers. These are the numbers that maybe you learned the very first ones when you were just a baby. You probably learned when you were watching like Sesame Street or something. 1, 2, 3, 4. And you probably worked your way up to 10, you probably worked your way up to 20, so on and so on. So natural numbers are all positive, and they are never ever going to be fractions. They're never going to be decimals. Think about what you learned as just a little kid. You started with 1, 2, 3, 4, 5, gone up. Okay. Pretty simple explanation for those. Notice these do what they do not include. Natural numbers do not include 0. They do not include negative numbers. In the circle, there are no negative numbers. In the circle, we don't have any decimals, and we'll talk about square roots in a second. Let's move up. So the next category, we're going to just start adding numbers to natural numbers and see how the definition changes. Whole numbers now are what we're talking about. Notice the whole number circle that I've highlighted in green includes natural numbers. Whole numbers now start to include 0. So now all of these include 0, 1, 2, 3, so on and so on, and it just goes up from there. Never negative still. We do not include decimals, do not include fractions. Now here's a couple really thought-provoking questions. Alright, are you ready? Are all whole numbers going to be natural numbers? Now whole numbers could include 0, 1, 2, 3, all the way up again. Not always. Not always are whole numbers going to be natural numbers. Why? You could have a whole number that's 0. Does 0 qualify as a natural number? Nope. Nope, it doesn't. Does not. But here, do all natural numbers qualify as whole numbers? 1, 2, 3. The answer is yeah. They're all going to be. Why? Because whole numbers include the circle natural numbers. You can think about it that way. Okay, so let's add a few more rules to this. When we add another rule, we're going to call that integers. And what we're going to add to the rules of all whole numbers and natural numbers is that integers include, what do you see here? Negatives. Integers always include negatives now. No, we're not including the negative decimals, and we're not including the negative fractions yet. These are going to be nice, pretty numbers. I think that if you don't have a fraction, you don't have a decimal, it's a pretty number. Yeah, I just remember it that way. It's easier for me. So I have natural numbers, whole numbers, integers we've talked about now. Integers actually include -1, -3, -4, 0, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everything that this green circle has in it will be an integer. Now, here's the toughie questions. Integers include negatives. Notice the definitions over here. Are negatives included with natural numbers? Are negatives included with whole numbers? Nope. So will an integer always be a whole number? No, because if you have -1, that's an integer. It's not a whole number. It's not a natural number. Let's talk about 0 now. Does 0 qualify as an integer? Does 0 qualify as a natural number? Oh boy, what did I do? 0 is in fact an integer, but 0 is not a natural number. So, alright. How about natural numbers? Are all natural numbers always going to be integers? Think about it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, they will always be integers. They are always going to be integers. What about -4? Which ones does -4 qualify as? Only an integer. Why? Because it's negative. Alright, I think we beat that one to death, so let's move on. Beep, beep, beep. Okay. Now, let's go with all rational numbers. Circle. Alright, rational numbers. What do you notice about this guy, that guy, that guy, that guy, that you haven't seen in the inner circles before? Yeah, that's right. We have fractions, both positive and negative, and then we also have decimals. And the funny thing about this hat on the decimal is that means that we have 7.12121212121212, and it goes on forever and never stops. This hat means that whatever's underneath of it repeats. So make the distinction here. We have 11.23 and it stops. Here we have a decimal that repeats forever. Rational numbers are fractions and decimals. Okay? You guys already know that you can write a fraction as a decimal, always. But notice, the rational number decimals either stop or they terminate, another way to say it, and rational numbers are going to either go on forever and repeat. So 2 rules. Rational numbers could be anything inside, and rational numbers stop. Think about it. We have 1, that stops. 2, it stops. 0, stops. -1, stops. It doesn't go on forever. Now, a lot of you wise guys are going to say, Miss Evick, but I could have 1, and you could follow it up with a lot of zeros that go on forever and hold place values. And I'm going to say, yep, you're right. Good for you. You made a connection. However, zeros don't count as repeating. We're not going to include them in our little quest to find our rational numbers. So, please note that. Get rid of all those. Boom. Alright, so, think about it. You have repeating decimals and terminating decimals. That's it that qualify as rational. Again, fractions can always be turned into decimals. That's why I say that. So, let's think about this. Let's have the hard questions. Will a natural number always be rational? The answer is yep, it will. Rational numbers include everything in this green circle. Is a whole number always going to be rational? Yeah, it is. Is an integer always going to be rational? Yep, it's in the green circle. Hard questions now. If I have 3/4, if I write it out as a decimal, this is actually 0.75. So these are equivalent. Would these be integers? The answer is no, because these are fractions and decimals. Everything in here, natural, whole, integers, they don't include fractions and decimals. Keep that in mind. Alright, I think we're good. So, let's get rid of all that. And I want to talk about irrational numbers now. Just irrational numbers. And why are they different than the rational numbers? So let's highlight this circle. Notice something that's very specific to this circle. These are only numbers that have decimals. They could be positive or negative decimals, but they go on forever. And do you see a pattern here? 7, 1, 8, 2, 8, 1. I don't see a pattern. These guys are decimals that never ever repeat and never ever end. Pi is never ending, and imperfect squares are never ending. Anything that is irrational stays in that category and can never be natural whole integers or rational.